Okay, you haven't done any processing on your own yet. Okay, yeah, even though this is a 3 plus 0, but we still need to I mean, we can still anyway implement some hands-on, okay, in as part of the learning process. Okay, we cannot be entirely theoretical over here. Okay, so minimum of 2, okay, will be required. Okay, from your side. Later on, me and Yuha will be giving you out what are the things that you need to do as part of your assignments on the practical side. Okay. Okay, assignments can be anything. Assignments can be theoretical based, can be technical based. Okay, so we should have some technicalities as well. Okay, just to get you familiar with the software, the data, and so on. Right. So I think minimum 2. Okay, I will give you out to the details. I think at least one will be from the hyperspectral processing side. Another one can be from the radar, Lidar. Another one can be from the GIS and the GPS parts. Okay, I will let you know. I mean, what are the details? But okay, we'll think about it later. Anyway, what is important today? Before we go into the Lidar and radar processing. Okay, before we go to that. I would also like to brief to you on your test 2. Okay. Everyone can hear me well. Huh? This is very important.
Yeah.
Okay, good. Okay, so I hope that everyone is fresh today. You have got your breakfast, right?
Yes, sir.
Okay, very good. So all of you are back in UPM now?
Yes, Doctor.
Okay.
Yes, Doctor.
So before I start my briefing, can you please switch on your camera for a while for me to record your online attendance as well as signing up the form, so don't forget. Okay, so semua nampak happy after Hari Raya. Okay, I hope that you have got a very nice Raya break. Everyone is back to UPM safely. Okay, good. Okay, please everyone switch on your camera for a few seconds. Okay. So do you have any like a Raya celebration at the departmental level? Apa-apa celebration ke di department? Ada. Ya,
I think there is no Raya celebration.
no Raya celebration. Oh,
Dinner next week with Raya team.
Next week ada apa?
Dinner. With Hari Raya team.
Oh, okay, dinner. Oh, right. Okay, thank you very much. Okay, thank you. Okay, for switching on your camera for a while. Okay, very good. Don't forget to sign your attendance. Okay. Okay, so let me brief you your test 2. This is very important because immediately after I give you out this information, you need to quickly form your groups. okay, and also your topics. Okay, so um, I will be sharing the screen now with regard to test 2. Okay, can you see my screen?
Yes, Doctor.
All right, good. Okay, so your test 2 will be in a form of group oral presentation, yeah, right? So as you can see, okay, from the document, which I will be sharing later on Putra Blast as well. Okay, so you need to form a group, okay, and for each group, you're supposed to have 4 students. Okay, so but I just got an information that one of your classmates is already quitting the course, if I'm not mistaken. Is it correct? Initially, we have 32 students, but one student already basically quit the entire course, if I'm not mistaken. Is it true? Quit the entire program.
I'm not sure, Doctor. We don't have information about that.
Okay, this is something that I just got this week. Okay, so one student will be out of the class, so we will have instead of 32, we will have only 31. So probably one group will have only 3 students. Okay, so I think it is still okay anyway. Okay, these 3 students are still fine. Okay, so what you need to do for this test 2, okay, you need to form the groups, okay, with 4 students, or one group will have 3 students. Okay, you are required to discuss, okay, you need to do some research, okay, and after that you discuss and present, okay, the outcome of your investigation or your research related to the use of geospatial technology in civil engineering. Okay, in your presentation, okay, you need to demonstrate, okay, on how, okay, you have to demonstrate and explain, okay, on how remote sensing, GIS, and also GNSS and other related geospatial technologies can be used in a civil engineering project or a civil engineering application. Okay, so you need to quickly form a group immediately after this, right? And from your group discussion, okay, you need to identify what will be the topic that you will be working on. Okay, so just to give you some ideas, you can do things related to anything in civil or environmental engineering, or anything that are still related. Okay, so there are so many things that you can touch upon. Okay, so you have transport, for example, highway engineering, topics on natural disasters, okay, determination of suitable sites for construction, development, environmental issues like pollution, natural resources utilization, sustainable development. Okay, there are so many things that you can work on. Okay, so in this we call it in this assignment, or in this test, okay, you are not just going to present on the theoretical part, okay, but I also would like to see maybe some demonstration of how you utilize remote sensing data, GPS data, GIS software, and so on. Okay, as what you call it, as a demonstration that you understand the process. Okay, and you can do the hands-on on that. Understand? Okay, it's not just a theoretical presentation, but also theoretical plus some output from your hands-on. Okay. Okay, so the assessment for this test will be based on your oral presentation in groups, okay, as well as the PowerPoint slides, okay, that you will submit. Okay, so this is an open-ended. Okay, you can go and find all the materials, the data. You don't have to use a huge amount of data, just some samples of data to demonstrate. Okay, let's say for example, if you choose a topic on the use of geospatial technologies in road design, for example. Okay, so how are you going to use GIS, GNSS, remote sensing to help you in road design, for instance? Okay, so besides discussing about the theoretical flow of the things that you need to do, you also need to find maybe some samples of satellite data, okay, for your specific area of interest. Maybe, for example, you can propose, okay, to develop a new highway, okay, for a specific area. Okay, so you can try to get maybe Landsat data or Sentinel data for that particular area. Okay, you can have lots of data coming from open source, open source websites, okay, from NASA websites, from and so on. There are so many things out there that you can try to compile and show that you, based on the theory that you have presented, okay, this is the output, okay, based on your own processing. Okay, so it's something like that. So it is very important that you must demonstrate the use of some real geospatial data in this particular project. Okay, and it is also very important to note that, okay, it should be no overlapping, okay, in terms of the topics between the groups. Okay, so meaning that it should not be like I would not allow, like say for example, 2 or 3 groups working on road construction. All right, so your topics for every group must be unique. Okay, should be no overlapping. Okay, but you need to propose to me first your topic, okay, on the basis of first come first serve. Okay, so meaning that if you quickly form your group, quickly brainstorm and come up with an idea of what you want to do, you need to let me know quickly. All right, so first come first serve. Basically, who come first with the topic, I will lock it. Okay, for the others, if they come later with the same topic, I will not allow. I will ask them to do a new one, okay, or a different topic. Right, so I'm giving you, let's say for example, 1 week, okay, to think about it. But I believe that you can you can come to me even earlier than that, okay, with your topic. Okay, don't wait until next week, okay, to come with the idea, okay, because you need to immediately start with this particular project quickly, because your presentation will be on the 10th of June. Okay, so basically now it's already, what is it, week 7 or week 8 for you? 7, isn't it?
Week 7.
Yeah, 7. So you have like 1, 2, 3, 4. You have like a week, okay, to do this project. So you have to be fast, okay? So you don't have to make it very big, this project, okay? You have to control the limit, okay? But you are free to discuss with me or with Mr. Yu Hao, okay, in order to polish your idea, yeah, okay. And then later on, when you do your presentation, later on will be me and Mr. Yu Hao will be assessing, okay, several parameters, okay, for the marking. For example, we're looking at the content, the quality of the content, or the quality of your investigation, okay, and the way you organize, okay, your group presentation and the reports, and also the quality of your delivery, and also the ability to answer questions, right? Okay. So, do you have any questions with regard to this test 2? Anything? Any concern?
I think so far we have no question, Doctor.
Okay, very good. Okay, kalau if you can come up with the topics and the groups by the end of today, that will be even better. All right, so that I can quickly guide you with your topic, because you have only 4 weeks.
Okay, there.
Okay. Yuhao, so you have anything that you like to add with regard to this test?
Okay. Yeah, Doctor. The student, you all can also use open source satellite images that, for example, I have demonstrated earlier, Sentinel-2. You can download from the Copernicus or the USGS website, and yeah, so you can consider that for this open source or freely available satellite images in your project.
Yeah. Yeah, I mean, the students are free to use any data, either it is open source or non-open source, provided that you have got permission to use the data, right? So open source, there will be no problems in terms of the permission. But if you are using some data, maybe from other lecturers, from maybe government organizations, you can use that as long as you have got the permission to use it. Okay. Unless you are using open source, it should be no problem. But there will be a lot of data that you can obtain from open source. Okay, so you can also work on something. Let's say, for example, giving you another idea is, let's say, for example, we have the Houston hyperspectral data. We have Japanese hyperspectral data, if you like. Okay, if you also like to investigate, for example, the impact of using different machine learning algorithms to extract man-made material, for example, you can also work on that. Okay, this is also can be considered as an application, because when you do a project, it is the focus of your project can be very application oriented, or can be also be process oriented. All right. So if your project is about investigating the feasibility of the use of geospatial data for a specific application, okay, so maybe you can develop, okay, the procedure, okay, the workflow, okay, until you obtain the final output that of certain satisfying criteria. But another way of doing this investigation also, you can work on the engine. Okay, you can work on the processing engine. Let's say, for example, you are interested in extracting building materials, for example, from hyperspectral data, or from multispectral data, or from radar or Lidar. Okay, so in order for you to extract the information about building materials in the scene, okay, you can also do what we call it algorithm-oriented research, okay, in which you will be doing some experiment, okay, in comparing the use of different machine learning algorithms, what will be the impact of the different hyperparameters on the output, and so on, right? So you can also use that, okay, because this is also very important, okay, because any algorithms that we use will affect the final output. So before the engineers can make a decision, okay, the decision at the end of the day will depend on what will be the output of the mapping. right? So if the mapping output is misleading, okay, your decision also will be misleading. Okay, so in order to make sure that the information is correct, the processing, okay, what is happening inside or during the process also is very, very important. So you have to investigate, for example, the impact of the use of different algorithms and so on. What will be the impact? Let's say, for example, if you want to investigate buildings, okay, the conditions of the building. If you're using, for example, deep learning versus the use of a support vector machine versus the use of maximum likelihood, probably the accuracy will be significantly different, okay, if you are using the different parameters of the algorithms. So this is also interesting to be investigated. So you can also work on something like that. Okay, but anyway, anything that you like to do, discuss with me first, get my green light, okay, and you can proceed. Yeah, please make sure that you discuss with me first. Okay, and anything else? Okay, so if you don't have any further questions, I think without further ado, today is we plan to have the final session on the remote sensing part. Okay, which we will be on Lidar and radar, because we haven't covered the processing part of Lidar and radar before we break for Raya last time. Okay, so maybe how you can explain to them what need to be done for the practical, or maybe you will demo the Lidar and radar processing now. Okay, I'll pass it to you, Yuhao, now.
Okay, doctor.
Thank you.
Okay, let me share my screen. Okay, I have shared my screen. Can you all see my slide? Okay, good. Okay, today we will move to the active remote sensing. As previously we have seen the analysis or the mechanism on the passive remote sensing and how passive remote sensing works. So perhaps let's recap on our previous theory. What is the difference of the passive remote sensing and also active remote sensing? As we have seen previously, passive remote sensing can only measure the light refractions from the object that have emitted from the sunlight. And while back to our topic today, we will see the active remote sensing that can provide the source of the illuminations, such as electromagnetic radiations. And the example of the active remote sensing is the Lidar and radar processing. So today we will also see how to process the Lidar and radar image using several platform or plugin such as the QGIS and also Snap software. And before we begin to the practical part, we will see some of the theory for this Lidar and radar. For the Lidar, which is the light detection and ranging, it is a form of the active remote sensing that use the light in the form of the pulse laser to measure the range, such as the variables distance to the Earth. So these light pulses will be collected in the form of the point cloud and then gathered together to generate the accurate 3D informations about the Earth's surface or the target object. By that, by generating the 3D informations, we can easily process further to get some of the some higher level of the analysis, such as the elevations, contour, and so on. And usually the Lidar will be collected in the form of the point cloud, and based on the returning of the laser pulse to a detector. So later on in the Lidar, we will see the number of return. That means the Lidar will be penetrated and return in a few number of times. And these are some of the primary components or basic components of a Lidar in the Lidar instruments. So the basic component of the Lidar instruments is scanner, laser, and GPS receiver. So as we can see from the sensor, it will emit the light illuminations and to the targeted object or the Earth. And when the light reaching the ground or the target object, it will reflected back to the laser sensor and received by the detector. So so the amount of the light actually will be in the form of the backscatter coefficients. So for example, previously we have seen the passive remote sensing, and then we have seen on how to process uh, the the images, such as the Landsat or Sentinel. And before we process, we will see the spectral signature, right? So, but in the Lidar and radar, they will in the form of point cloud, whether in the form of point cloud, the collections will be in the form of point cloud or the backscattering coefficients. So this will be the indications to represent which kind of object that have been reflected and received by the detector. So for this Lidar, later on we will process the Lidar data, and the locations is Houston University. And basically in the Lidar data, it will in the form of point cloud, and this data will be consist of 3 channels, C1, C2, and C3, that have variations of this wavelength. So this wavelength will represent the some kind of the penetrating power in terms of the frequency. But today we will take, or we will process one of this channel by taking their subsetting part. Okay, without further ado, I will demonstrate the Lidar processing first. And for this Lidar processing, we will be using some of the plugin called last2, which is the Qgis plugin. So we need to install the plugin first. Let me open the Qgis software.
that the latest version now, 3.22?
Yeah, 3.22 is the latest versions. Just a moment. Okay. Okay, so we need to install the tool first through the plugin. So we go to manage and install plugin. And we need to tap LASTOOL. And this tool is also particularly designed for this LiDAR processing. Okay, so when you see this LAS tool, you can just click install plugin. So I have already installed. So it is quite straightforward for this part. And after that, you can see at your right here in the processing toolbox, it will be we will be seeing the LAS tools. So these are the functions that we will be using later on. And I will also share the data after this practical class. Any one of you can record this section first and distribute or share to other students later. So later on you can try or repeat the step using the data that I will be distributing later. Okay, so now at your right we will see LS tools, and now of course we need to import the data. But before we import the data, as we can see, this starting from the up is the checking quality. That means we can use LAS tool to check the quality of the LiDAR that is in the form of the point cloud base. So to check the quality of the point cloud, we can also extract some of the basic informations from this point cloud, like the basic statistical information or some of the general information, such as the number of return coordinate and so on. So let us examine or access to these general informations of our point cloud data first. For this, you need to click LAS info, and then we need to input our point cloud data. So as we can see, this is our point cloud data that has been taken from one of the channel, which is C1. So this is today we will took some of the subset, the part that has been subsetted. So we take one of them, .las, and okay, so for this histogram you can just leave it, and this is just leave it for this. After that this output ASCII file, we can put it as a skip output, and once we have input our file, we can run it first. Okay, as you can see, the general information has been displayed here. Okay, let's look from the top. We can see file signatures global encoding. This is quite general. And offset to point data 229. Just a moment, I have a call. I pick the call first for a second, for a few minutes. I will be coming back. Okay. Yeah, I'm sorry. I just received the official call. Yeah. Let's continue our practical. Okay. Can you see this? I have shared my screen. Now, can you see the LAS info, right? Is it?
Yes.
Okay. So, after we have processed using last info, we can see the X, Y, G, and also the number of first return. How many number in our point cloud? So the number of intermediate return and the number of last return. So we can see the number of the returns. That means the return represent the pulses or the signal that has been received by the sensor. So number of single return, and also in this point cloud we can also see some of the general information, how many numbers that has been classified as unclassified, that means unknown, and also how many number of in our point cloud data has been classified as ground, building, noise, and bridge desk. And these informations will give us some of the basic idea for our point cloud data. And okay, so after assessing the basic informations using LAS last info, we can also visualize our point cloud data in an interactive way through using last view. So this is in the form of visualizations. So for this last view, we will also do the same thing, import our data, and maximum of number point sample, you can put this amount, and after that just click run. Okay. Yeah, I think this visualizations is in the form of 3D. So you can see at the open space of the blank space there, they will also have the red point upstairs and also the downstairs. And this is the visualizations of this point cloud data. And we can see the collections of the point cloud and combine together to form such object and represent the features on the ground. And this point cloud is basically has been captured by the sensor. So that's why we can visualize them in the and visualize our point cloud data. So we can see actually they have, this is all is the form of the collection of point. Okay. So now we can close that and we can proceed to the next one. For the next one, we can go to last generating the DEM. We can generate our DEM, digital elevations model, because the point cloud data can be processed and generate the digital elevations model that can be very useful to extract the height of the object. For example, uh, after we have processed and generate the DEM, the digital elevations model from our raw data, which is point cloud data, we can know the height of the buildings, or the height of this tree, the height of the crops, the height of any features that has been captured by the sensor. Okay, for this, you just search last DEM Pro. Last DEM Pro, there's under one of them. Yeah, last two DEM Pro. So to generate our DEM, so we need to click last two DEM Pro, and we need to fill some of the input. So in this case, we will use, okay, we need to input our directory. So this directory must consist of this point cloud data. So the point cloud data that is in the form of the LAS format. Here, las.las. So we need to input our provide our directory. So select folder, and input wildcard is in the form of LAS, not LAZ. Since point cloud, there are a few of the format, one of such as LAS or LAZ, and filter. Okay, so this is the filter. We can go, we can click the keep underscore class 2 by using this filtering, and the step size 1.0, elevations, and so on, and actual value. So attribute, we want to generate elevations, so we click elevations, but it will also generate the slope for us, intensity, and so on. But in this case, we will choose the elevations, and the output format is in the form of diff. And now we can save. We can provide the directory. After that, click run. Okay. Okay, so it has finished processing. Let's see. Okay, this is our product. Okay, we will try to open it. So go to layer and add layer and click add raster layer and click add. Okay. Okay. We can see the range here, 6.07 and negative 21.6. Let us provide some of the color range. Okay, and we can see from here is in the 1D image. Now we can display them or display them into the 3D, three-dimensional format or form. So we need to download one plugin, or we need to use one plugin called Qgis 23JS here. So to install the plugin, you can go to click the Qgis 23JS and install this plugin. Okay, so after the installations, we can click them and we can display them in the 3D format. So you just click here and you will see actually this strip line is an error, but that can be eliminated or processed further to remove this by using last split. I think I will try using that approach too, and we will see can we remove this or not. So just to ignore this, we can see like this is our product, and actually this area, because they have a negative, it means why it have the negative and 6. That means in the elevations, if we approach on some of the mean sea level before, so below the 0 it is under the mean sea level, is under sea level. So and anything that above 0, there's beyond the sea level. So that's why we will see in this place there are quite a few, and also we can also overlay. Let's overlay with the base map and see what is the feature. And before that, we need to set the coordinate first, and this is EPSG and AD83. Okay, we need to set the coordinate first before we overlay.
Why there is a green line there?
This is the error caused by the tools, because these tools because the memory is so large. So when it processed using these LS tools, it has this kind of tools, and we can try. I will also try to remove this strip line by using last split, LAS split. So that's mean when we when we execute the split, so we try to divide our point cloud data into a few of the to break the memory. I mean to reduce their memory. So and divide it into a few of the data, and then we process, and later on we merge them again. I will also try after this this display. We will try and whether we can delete this or not, or solve this line or not.
If let's say, for example, you just take a subset of the data, I mean, half of it, only half of it, maybe just a quarter of this data, this green line will appear or not? If let's say you do a subset just to demonstrate on how to process, okay, you don't have to do the entire data set. So will the green thing still appear?
I think it won't appear, but doctor, this is this actually they capture this is the already the one portion from the data acquisitions that captured by them, and although this can consider the subset since they have provided us, because as the raw data I show to you, C1, C2, C3, and for example C2, this is the every one of these file point cloud is the portion of this entire Houston area. So I think when they acquire this data, they go part by part. So this is so so I can only use one of them, one of the portion of them, and to process, and to reduce this strip line, need to split this one file, because since I only we have no choice, we need to use one of them, because this can also consider the subset, but we the only solution we can reduce or split this file into several portions, so that the size will be reduced, and later on we will merge them together. Now I will try. It's not taking long time now. We will see and can solve this or not. And before I show that, I try to overlay with the base map first. So okay, this is this as we can see here, basketball field. Just a moment. Just a moment, it needs some time to load. Basketball field. This red indications we can see is the basketball field. How about this green? Okay, this basketball field is below the 0. It's okay. I will try to use RGB images. And we overlay with the hyperspectral. What is the object for this green as it is? Yeah, you can investigate maybe later. Yeah, because the is it the see at least for this lidar we can see some of the feature like the basketball field and also the building here. Just a while in it is not responding. It's okay. I reopen it again. And I try to overlay, but before that we need to define the coordinate first, okay, so that it can overlay with our hyperspectral images. And we can put the color range so that later on we can differentiate the level of the elevations. Okay, so okay, so we can see the image has overlay with the hyperspectral image. And now, last time I have produced I have tried some of to split them. This is the product that I get. It seems the problem is still occurring. Now we can try. Let's try to splitting then and see this strip can be eliminated or not. Us to split.
Okay, I think this is taking quite a long time. I think you can skip for a while this last tool.
Okay.
I think you can briefly explain to them about radar. I think this one they can do it later as long as they know what the tools they need to use. Later on, you can give the details. Yeah.
Okay. Okay. Okay.
So yeah, maybe there is a need for a break for maybe like 5 minutes. Okay, and then when we come back, you can explain to them about the radar.
Okay. Okay.
And I want to give them more time for their group discussion. Maybe they would like to use the time for forming the group and everything, and come up with the idea for their test too. Okay, hopefully they can resolve that by today, so that we don't have to waste more time on their side as well. Okay, so yeah, we can take a break, okay, for like 5 minutes. We'll come back with the radar.
Okay.
Okay, so maybe the students, what you can do now, okay, I'm going to give you the opportunity, okay, to have a discussion, to form the groups and everything. Okay, can I give you something like 15 minutes for you to form a group and come up with ideas about what you're going to do for test 2?
Okay, Doctor.
Yeah. So just use this time that you have now, okay? You can create your groups and do perform some discussions. Okay, you can discuss now. Okay, maybe after 10 minutes, you can suggest to me your topics.
Okay, Doctor.
Okay, you can WhatsApp me, okay? Okay, so I have received some information regarding the groups now. Okay, I just received it from Nurin. Okay, so what I have now is I got 7 groups with 2 groups with 5 members. Okay, it's fine. Group 4 and group 7, have you decided on the topics? Okay, so for group 1, you have flood. Group 2, beach corrosion. Corrosion or erosion? Corrosion or erosion? Group 2. It's erosion, isn't it?
Yeah, I think erosion was done, but
Yeah.
we discuss.
Yeah, so erosion, not corrosion. Okay, group 3, transportation application. Group 4, landslide. Sorry, group 4, not yet. Group 5, landslide. Group 6, site stability. Group 7, no topic yet. Okay, right. Okay, so this is all, I mean, we have how many students now for all these groups total? $29. Okay, this is the total number of students that we have now for the class, 29, not 30. Let me check the SMP. For the ESMP, I have 30 students. Previously 31, but one student already dropped. So at the moment, I got 30. Okay, from the list you have given me in the list in the groups. What is the total, Nurin?
I think we have 29 students, but one is absent. I think Putri is not here. I think
Oh, Putri. Okay,
Putri, so there'll be one.
so which group Putri will be joining? Not
I
sure.
think Putri will be joining our group, the first group. I think, if it's okay for one
Okay,
group.
so you have 1, 2, 3, 4, 1, 2, 3, 4. So group 1 and group 6 will have 5. Huh? Yeah.
All right, Ada.
Okay, so group 4 and group 7, you haven't decided on the title or the topic? Not yet.
Yes, doctor, we haven't decided which
Okay,
topic we
all
want
right.
to.
Okay, so maybe you can decide after this.
Okay.
Right. Okay, so good. Okay, so you managed to form the groups quickly, efficiently. Okay, good. Right, wait a second. Okay, so Yuhao, you can continue with the radar.
Okay, doctor. Okay, okay. We have seen the LiDAR processing just now. So now we will proceed to the radar processing. And before I go to the practical part, I will just briefly explain the theory of the radar and also how the radar generally work. And radar is an active remote sensing that transmit the microwave radio signals and receive and process the backscatter radiations to detect the target on the ground, and it quantify the parameter of this backscatter signal. So the basic relevance to remote sensing is that the difference between the parameter of the backscatter signals and those of the transmitter signal is due to the mainly the interactions of the transmitter signals with the target. So as you can see, the bottom right below is basically for the radar. It the product or the backscatter signals, the final product that will be received by the sensor is it is the backscatter signal, or in other terms, in a more specific term, is called backscatter coefficients. But this backscatter coefficients is begin from the radar itself. First, it will transmit the microwave signal toward a scene. A scene here is called the target. For example, from the bottom right, the radar will transmit the signal to the tree. You can see from the bottom right. So it will transmit the signal to the tree first, and then after that, throughout the interaction process, the some of these backscatter signals will be reflected back and received by the signal or the detector. So the detector will receive the transmitted energy backscatter from the target or the scene, target of the object. So this target will can be buildings, trees, river, water, or sea, and any kind of the object from the ground. So what's the radar receive? The radar receive will actually receive in the form of echo that is called the electronic signal that will be reflected back to the radar and antenna that contain the locations and distance and also the informations from the ground. And also radar will observe the strength and the time delay of the return signal. So it is generally also in the form of pulses. So as radar, we can see it transmit the signal. but when it throughout the signal transmissions, they consist of a few of the reflections when it interact with the ground or the target. So there are basically three type of the reflections. So for these specular reflections, as we can see from the beginning, the radar when transmit the microwave radio signal to the object, for example tree, or for example water. So basically, because water will be having the specular reflection, that's mean you can see the signal transmit to the ground here, but it reflected or it backscattered away from the signal. So for these specular reflections, the signal is transmitted away. So by having by in this scenario, when the signal transmitted away and the radar or the sensor will not be able to receive because it transmitted away. So it is called specular reflections. So for these corner reflections, I'm sorry, it should be the diffuse reflections. Diffuse. Typing error. Should be diffuse. So for this, so another type, the second type of the reflections is the diffuse reflections. So when the radar transmit the signal to the object, and you can see it's backscatter, the interactions is quite scattered and evenly distributed. So in this sense, the interactions between the signal and the object is quite sparse and also unevenly interacted properly, but some of the backscatter signal will be reflected back to the signal will be reflected back to the sensor. So in this diffuse reflections, the radar will receive some of the backscatter signal from the target or the object on the ground. And the third type of the reflections is the corner reflections. In the corner reflections, actually is the third type is usually happen on the building, which we can see on the building. They have the space of the building, the signal will transmit the radio signal. The signal will be transmitted, and then when it will reflect. When the reflections was in the form of the corner reflections, that means it will have some of the kind of the double bounce when it interact with the building. So actually this double bounce, first it will transmit and reaching the ground first, and then it won't reflected straight away to the signal, but it will bounce. The light will bounce to somewhere. If the building we can see is in the square space, so maybe it will reflected in some part of to some part of the building first, maybe yeah. So after that only it will finally it will reflect back and received by the detector or the signals. So now let us begin to the practical. Okay, to download the radar image, we can download Sentinel-1 image, because Sentinel-1 image is belong to the radar. And last time we have download the Sentinel-2 image. There's the optical data. So now we can copy this link, but this link is actually the same that we download. It is where the place we download the Sentinel-2 image. So okay, I think I will quickly show this because it's quite easy and straightforward. You just do the you just draw the study area, and then provide the sensing period by giving the date of your study, and then at this term you need to choose missions Sentinel-1, because last time based on the previous sections we have worked on the Sentinel-2. So now we will go for the radar image, which is the Sentinel-1A, and you can choose the HH plus HV. This is the polarizations of the radar and type of product type and so on. But in general, you can just proceed with these two and then click this searching. Okay, so later on it will search it for you, and then you can choose. Yeah, so this is the searching process. So you can view the product detail. This is the same from what we downloaded the Sentinel-2 last time. So now without further ado, because we will straight away go to the procedure in processing the radar image. So before that, you need to download to process the radar image. It is recommended to download one specific radar software called Snap. That is designed specifically to process the radar. I will share this link in the chat box here. Okay, so we need to download the Sentinels. We need to download the Snap software by clicking the main download, and then after that it will and then you just do the installations, and it is quite normal and straightforward. So without further ado, there are several procedures for when we want to process the radar image. So these are the procedure. These are the pre-processing stage, and we need to do some of the noise removal, thermal noise removal calibrations, terrain flattening, multi-looking speckle filter, geometric corrections, and after that we can only proceed to the classifications and also accuracy assessment. So without further ado, I will just import the radar image by clicking the open product, because this is the Snap software. And okay, so when we download the Sentinel-1 image from the website, it will in the form of the zip file. And in this case, we no need to unzip them first. We just click the raw data. We no need to unzip them, but we just straight away open the Snap and click the open product. And after that, for the bands, you just choose one of the type of polarizations. In this, case, I will click the amplitude VV first. Okay, so this area I think is around the Selangor, some part of the Selangor. Okay, you can see this the radar image in the form of the VV polarizations, and radar image usually consists of general in general term, it consists of VV and VH. So it can also be a simulated bands VH and VV. So these are the two type of the polarizations. And now, before that, before we process the pre-processing, we need to subset first. So I will subset first. Okay, so we need to subset first. Just a moment. Just wait. Okay. Okay, so we can subset by adjusting this small box. Okay, you can subset like that, and then after that you click OK. Okay, so after that, when you click OK, because since I already processed before, so I will just pull out the subsetted product. So when you click OK, it will process, and then later on it will show the subset here. So which is the subset underscore 0. So I just open. So when this is the product, so when you run that, it will produce this product. And for this raw data, you can just close the product, and then you can display your latest image, which is the subset image. And you can see this is the subset image. So one of the advantage for the subset, one of the advantage of the subset as the image has been reduced as compared to before. So when you run the classification, it will not cost so much of computational power from your desktop. So now let's if we have this subset image, we can go to proceed with this procedure. So first we need to do the thermal noise removal. Okay, I rerun again. Typical today. Actually, we will have temp, but it's okay. If not, I will also just show that thermal noise removal. Okay, S1 thermal noise removal, and our source product is the subset image, and the processing part will be select and click run. Okay, let's wait for the processing. And this is the our first in our processing stage, which is the thermal noise removal. So for the previous one, for the subset image, we no need that. So since we have the product, the latest product, and